Welcome back, student, to this video. And in this video, I'm going to discuss about a new topic, that is potentiometer. So this potentiometer, it is actually, it is like a circuit only, which consists of a very long wire, usually in the range of 4 meters to 10 meters. Now this wire, they are connected parallel to each other, they are connected in series like this through a copper strip. Okay, so don't get confused, though it may look to you like a parallel connections of wires, but this is a series connection, because look at the directions where the wire is going. The wire starts from point A, it goes to this point, and then we turn the wire in this way. Again, this is the turning point, right? So this is nothing but it is a series connections of wire. So these wires, they are of uniform area of cross section. Okay, all right. Now these 2 points A and B, they are connected to a battery, a key, and a rheostat. This rheostat here, though you may not have seen about it, but we shall see about this rheostat when we do the practical, and we will also see about what is the function of this rheostat. So this rheostat here, it is actually used to adjust the constant current to pass through the wire. Okay, now this whole circuit here, which includes the battery, the key, and the rheostat, together with this wire of a potentiometer, this whole circuit, it is known as auxiliary circuit. Okay, so that is about the construction of this potentiometer. Okay, now we will see how this potentiometer works. Okay, so I have written here point wise so that you will remember about the points about the potentiometer. So the first point is, this potentiometer is an ideal voltmeter. When I say ideal voltmeter, it means it is a voltmeter which measure the potential difference or the EMF of a cell very accurately. But that voltmeter where we have in the laboratory, when you measure the EMF of a cell, the value which is given by that potentiometer, the value which is given by that voltmeter, it will not be correct. Let's say you are getting, if you measure the potential difference between the two terminals of a cell, let's say you are getting 3 volt. So now this 3 volt, exactly, it is not the EMF. EMF, it may be greater than 3 it may be greater than 3, let's say it is 3.5 volt. So you may wonder why this EMF, when you measure with a voltmeter, we are not getting the real value, but we are getting the value which is lesser than its real value. The thing is, because when you measure the EMF, we are connecting our wires to the voltmeter. So that wire, which is the connecting wires, they have got some resistance, and so the current also is passing through them. So as the current is passing through those wires, so therefore there will be a drop of potential across those wires also. So that is why the EMF, when measured by the voltmeter, it is not exactly the real value as 3.5, but you may get just 3 volt. Okay, so now in order to overcome that problem, or in order to measure the potential difference or the EMF very accurately, now we use this potentiometer. So this potentiometer, when you measure the EMF of a cell, it will give the exact value or the accurate value of the EMF. It is unlike the um, voltmeter. Now, the first point is EMF is an ideal voltmeter that I have explained because it gives the exact value. Number two, this potentiometer, it is used to find the EMF or the potential difference of a cell. And the third point is this potentiometer, it works on the principles that when you when a steady current, right, it is sending by the battery. Now this steady current I will be flowing through the wire. Now if you consider any 2 points, let's say this point A and point J, if you take a voltmeter connecting the positive of the volt here and the negative of the voltmeter at J, then this voltmeter, let's say, it tells you about the potential difference between the 2 points. And if this length AJ in this case is L, then it is found that this potential difference between the 2 point A and J along this wire, it is directly proportional to this length. Fine? Okay. Now, I will write V is equals to, instead of writing directly proportional, I will remove the proportionality sign. I will write with some constant and then times L. Here, this K is a constant of proportionality and it is called the potential gradient. Potential gradient. Okay. We can also find out K from here. So when you find out K from this equation, you will get K is equals to V upon L. So that means this K, it can be defined now as the potential drop or the potential difference per unit length of the wire. So similarly, when we look at this equation 1, we can tell about the SI unit of this potential gradient. So the SI unit of potential gradient in this case, it would be volt per meter. Alright, or I will write it this. Or in symbol, I'll write Vm minus 1. So this is the SI unit of potential gradient. Okay. Now, when you plot the graph between the potential difference and the length of the wire by taking length along x-axis and potential along y-axis, then what you will find is the graph here, it comes out to be a straight line which is passing through the origin. Okay, this is very understood because from here V is directly proportional to L. It means that when the length is increasing, the potential difference also is increasing. And when the length is decreasing, the potential difference also is decreasing. So that is how, when you plot the graph, you get a straight line graph. Okay, so this is just the introduction about the potentiometer. Alright, so look at this figure again. This is a wire from here to here. The length of this wire is 1 meter. Similar, this length is 1 meter, 1 meter, 1 meter. So it means that every 1 meter wire here, they are connected in parallel using a copper strips. Apart from that, we will also see in the practical that in this potentiometer, we have a scale. We have a scale which is 1 meter long. And this scale, it is fitted parallel to these wires. So that is how, because of the presence of the scale, we call this instrument as a potentiometer. So when I say meter, it means this is the 1 meter, because the scale using here, it is 1 meter. So that is how this becomes a potentiometer. So in the next video, we shall see about the applications of potentiometer, and we will see how this potentiometer, right, it is used to to measure the EMF of a cell, to determine the internal resistance of a cell, and so on.